All right, welcome. If you've ever played a video game or even just fiddled with a spreadsheet, you've actually been using this super powerful hidden tool of the digital world. And today, we are going to unbox that very concept, the Matrix. I mean, think about it. The modern world literally runs on data. Everything from your school grades to the incredible graphics in your favorite video game, it's all just information. But that data needs a way to be organized to be useful, right? So that brings up a really big question. How do we actually speak the language of data? How do we work with all of it, all at once?
Well, the answer is surprisingly elegant and incredibly powerful. Meet the matrix. At its heart, a matrix is really just a simple grid of numbers set up in neat rows and columns. It's this beautiful way to organize really complex information so we can actually work with it.
Okay, so to really get what makes them tick, let's break down the basic anatomy of a matrix. The essential building blocks.
And the structure is it's so simple. The lines of numbers going across, those are your rows. The ones going up and down, those are your columns. That's literally it. Every single matrix you'll ever see is just built from these two basic parts. Okay, and here is the one rule you absolutely, positively cannot forget. You always say the number of rows first, and then the columns. Just burn this into your brain. R before C, always. And that R before C rule? It leads us right into how we talk about a matrix size, which we call its dimension. And finding it is a super simple three-step process. First, you count the rows. Second, you count the columns. And third, you just state the dimension as rows by columns. So let's look at a quick example here. We can see 2 horizontal rows, right? And 3 vertical columns. So we'd say its dimension is 2 by 3. See? That's all there is to it. And a really important note, we don't multiply them to get 6 or anything. The dimension is just a description of its shape, 2 by 3.
All right, so now that we've got the basics down, let's see what we can actually do with them. We're going to start with the most fundamental operations, addition and subtraction. But before we even touch a single number, there is a golden rule. You have to know this. If you want to add or subtract 2 matrices, they must have the exact same dimension. I mean it. If one's a 2 by 3 and the other's a 3 by 2, nope, can't do it. They have to be a perfect match.
So adding matrices, it's a super straightforward 2-step deal. First, you just confirm the dimensions are identical. Once you've got that check mark, you just add the numbers that are in the matching spots in each matrix.
Yeah, the whole process is all about those corresponding positions. You take the number in the top left of the first matrix and you add it to the top left of the second. Then you do the same thing for the top right, the bottom left, and so on for every single spot. Each pair gets added together, and what you get is a brand new matrix that's the exact same size as the ones you started with.
So, what about subtraction? Well, I've got great news for you. It works pretty much the exact same way. Step 1, you confirm those dimensions are identical. And step 2, you just subtract the numbers in the corresponding positions. Yep, the process is basically a mirror image of addition. We take the number in the second matrix and subtract it from its matching partner in the first one. And you do this for every single position to get your final answer. The big takeaway for both adding and subtracting is that it all happens element by element, one position at a time. Okay, let's shift gears a little and look at something a bit more abstract, but trust me, it's incredibly useful. Every square matrix, and that just means it has the same number of rows and columns, has this special single number that belongs only to it. We call it the determinant. And one of the first things we got to get straight is the notation, because it's super important. A matrix is written with square brackets or parentheses, but the determinant? That's written with straight vertical bars. They look different because they are different things. A matrix is a whole grid of numbers, but its determinant is just one single number that we calculate from it.
So, how do we actually find this magic number? Well, for a simple 2 by 2 matrix, the formula is nice and easy. You multiply the numbers on the main diagonal, that's top left to bottom right, then you subtract the product of the numbers on the other diagonal, top right to bottom left.
Let's actually try that out. So we multiply down the main diagonal. Then we multiply up the other diagonal. And then we just subtract that second result from the first. And boom, what you're left with is one single number. That's our determinant.
Okay, but why do we even care about this one number? Well, it tells us some really critical stuff about the matrix. For example, if the determinant works out to be 0, we call that matrix singular.
And that's often a huge red flag in a lot of applications. It can mean that a system of equations you're trying to solve doesn't have a nice, unique solution.
You know, kind of like animals in the wild, matrices come in all sorts of different shapes and sizes, and each one has its own special name and its own properties. So let's do a quick field guide and meet some of the most common types you'll run into.
All right, let's run through these quickly. A row matrix? It's just got one row. A column matrix? You guessed it, just one column. We've already met the square matrix, where the rows and columns are equal. A null matrix is the easiest of all. Every single number inside it is a 0. And finally, you really want to pay attention to the identity matrix. It's a square matrix with 1s running down the main diagonal and 0s everywhere else. This one is super important because it acts kind of like the number 1 does in regular multiplication.
All right, so let's quickly recap the main takeaways here. First, matrices are just awesome tools for organizing data. Second, when you're adding or subtracting, the dimensions have to match, no exceptions. Third, the determinant is that special single number we can get from any square matrix. And finally, matrices come in all these cool specialized forms like row, square, and the super important identity matrix.
And that about wraps it up. Now that you've kind of unboxed the basics of the matrix, the real question is, where are you going to see it next? Because I'm telling you, these ideas, they're the foundation for solving massive systems of equations, for rendering the amazing 3D graphics in the virtual worlds we all love, and even for powering the artificial intelligence that's literally changing our world as we speak. The possibilities are, well, they're pretty much endless.